Lesson 17, From Rates to Ratios. Goals. Given a rate, you can calculate the unit rate and associated ratios. Recognize that all ratios associated to a given rate are equivalent because they have the same value. Example 1 is just kind of a warm-up just to remind us about ratios and how we can write them. So it just says write each ratio as a rate. So the ratio of miles to hours is 434 to 7. I can do it like this as a fraction. 434 to 7. And if I want to do it as a rate, what I'm doing is I'm adding in the units with the numbers. So this is miles, and it's per hours. And that's how I could write a rate. So again, it's very similar to ratio. We're just adding in our labels because it's miles per hours. These are going to be different things, different values, and they represent different measurements, units of measure. B, the ratio of laps to minutes is 5 to 4. So again, we have 5 to 4, but we're going to add in those labels. So we have 5 laps to 4 minutes. What I can do with these two rates is reduce them down to their unit rate, and that's just kind of like finding the value of a ratio where you're simplifying it, and almost always the ratio or the rate is going to have a denominator of 1. It's usually going to be, well, how much does something cost per 1? Per 1 day, how much money am I making? Per 1 hour? So for this one, if I wanted to find this in 1 hour, and again, my denominator is a 1 there in that fraction. So how do I go from a 7 to a 1? Well, I divide by 7. So I would want to divide 434 by 7, and I can do that off to the side. If you don't know that in your head, if you can't solve that. And so 7 times what is around 43? Well, 7 times 6 is 42. And then I would have 14. So 7 goes into 14 twice. So that means that it's 62 miles per 1 hour. This one over here, if I were to divide both of these by 4, you can't really divide 5 by 4 evenly. So we could write that as 5/4 laps per minute. And I'm going to just add it above the picture. And so again, the answer would be 5/4 laps per minute. A lot of times we don't really put decimals or fractions within the fraction itself because it kind of looks weird. You could tell me that the person swims 1 1/4 laps per minute, or 1.25, 1 2500ths. But we can go ahead and leave it in this format as well. So from example part 1b, I just want to write the ratio, rate, and unit rate from this example. So the ratio, I could write it like this, 5/4. The actual rate is 5 laps to 4 minutes. And the unit rate is 5/4 laps per minute. Okay, we're going to go ahead and go to example number 3. We're going to do this with a tape diagram, and we're going to see how this can be useful when needing to solve problems involving rates. Dave can clean pools at a constant rate of 3/5 pools per hour. What is the ratio of pools to hour? Well, that would be 3 to 5, because it says 3 to 5 here, which is pools to hours. How many pools can Dave clean in 10 hours? Well, here's pools, which represents 3, and here's hours, 1, 2, 3, 4, 5. And the hours is 10, here, 10 hours. So would I put pools equals 10 or hours equals 10? I hope that you say this last one, the hours. So these 5 boxes need to add up to 10. We have to figure out how much should go in each box if it has to have the same number. Well, take your 10 and divide it by the 5, and you will get 2. 2, 4, 6, 8, 10. Or you can do 2 times 5 is 10, whichever method you want to check, but that needs to equal 10. Because these numbers are 2, the numbers that go into these boxes are also 2. So how many pools can Dave clean? 2, 4, 6. Because 3 to 5 is the same as 6 to 10. I'm doubling my numerator here, the first number, and then I'm also going to double that denominator, the second number. How long does it take Dave to clean 15 pools? So if I'm using the same ratio, do I want to put 15 down here? I hope you say no. 15 is pools. So that needs to go at the end of pools. So I have 15 that I need to divide evenly into 3 boxes. 15 divided by 3 is 5. 5, 10, 15. Since I put 5 in those boxes, I put 5 in the boxes below. If there's 5 boxes and 5 in each box, that makes a total of 25. I can check this by, again, taking my 3, multiplying by 5 to get 15, and then I take my 5 and multiply that by 5, and I get 25. So I can use that check method. I'll draw it out here. To remind you that you need to multiply by the same thing. Here I'm multiplying by 5, and from here to here I'm multiplying by 5. So that checks. That's the check method if you didn't remember. Okay, here's an example that we're using the double number line diagram. It's just another method that you can use to solve for these rates. It says Emmeline can type at a constant rate of 1 to 4 pages per minute. Emmeline has to type a 5-page article but only has 18 minutes until she reaches the deadline. Does she have enough time to type the article? Why or why not? Okay, I have some numbers down here already pre-done. We need to add the pages numbers. So here's going to be 0 because 0 and 0 match up. So if this is pages 2 minutes and I have 4 minutes, then I would want 1 page. If I'm going to duplicate my ratio and add by 4 and add by this number, then I'm just going to increase this by 1s because I'm going to add 1 and I'm going to add 4 to get 2 to 8, and then I'm going to keep going and add 1 across the top, and I'm adding by 4s at the bottom to keep that ratio 1 to 4. So again, if it says that Emmeline has to type a 5-page article, 5 pages is right here. This is how long it would take her. Take her 20 minutes. It says she only has 18 minutes until she reaches the deadline. So will she have enough time to type that? No, because typing 5 pages will take her 20 minutes. She will be 2 minutes over the deadline. Using the Venn diagram, how much time will it take Emmeline to type a 7-page article? Well, if we go to 7-page and we go down to the time, we can easily see that it will take her 28 minutes. Our next example, Xavier can swim at a constant speed of 5 to 3 meters per second. What is the ratio of meters per second? 5 to 3. Xavier is trying to qualify for the national swim meet. To qualify, he must complete a 100-meter race in 55 seconds. Will Xavier be able to qualify? Why or why not? Okay, so what we can do is use a table. I can put in 5 meters to 3 seconds. I can go ahead and multiply those numbers. I can multiply by 2 to get 10. So I'd multiply this number by 2 to get 6. And then I can go ahead and multiply by 10 to get 100. If I multiply this by 10, I need to multiply this number by 10, and I would get 60 seconds. So will he be able to qualify? Well, he can go 100 meters in 60 seconds. So he will not qualify because he needs to be able to do it in 55 seconds. It's going to take him 60 seconds to do that. Here's another question that's about Xavier. It says he's also attempting to qualify for the same meet in the 200-meter event. To qualify, Xavier would need to complete the race in 130 seconds. Will he be able to qualify in this race? So if we're using the same ratio, I can put 100 meters to 60. And if I need to do 130 seconds, I could do 120 seconds, multiplied by 2, so this is 200. And so I can see in 200 meters, he can do that in 120 seconds, and he needs to be able to do it in 130. And so he's 10 seconds faster, so he would be able to qualify in that event. We're going to also talk about Lesson 18, finding a rate by dividing two quantities. There's just a few examples here that we're going to do. Our goal is to interpret a rate as division of two quantities or a fraction. And so our first example says, at Fun Burger, the burger master can make hamburgers at a rate of 4 burgers per minute. In order to address the heavy volume of customers, he needs to continue at this rate for 30 minutes. So our question here is, if he continues to make hamburgers at this pace, how many hamburgers will the burger master make in 30 minutes? So what I can do here is write it as an equation. When I'm multiplying by 30 minutes, really this is the numerator. And so when I have minutes and minutes, we've kind of talked about cross-reducing just briefly, but if you have the same number that's opposite, you can cancel those out. So that's what we're going to do with our minutes here. These minutes are going to cancel, because think about if you have 30 30ths, you have one whole. So the same thing if you have minutes, 1 minute divided by 1 minute, it's kind of gone. You don't have that anymore. So I'm going to multiply 4 burgers by 30, and I'm going to get 120 burgers. And that's the mathematical way to do that one. Number 2, Chandra is an editor at the New York Gazette. Her job is to read over each article before it's printed in the newspaper. If Chandra can read 10 words per second, how many words can she read in 60 seconds? So I'm going to go ahead and copy down my 10, and I'm going to put words per second, and I'm going to multiply by 60 seconds. Again, this is pretty much going to be over one whole. I'm going to cancel out my seconds. And so I have 10 words times 60, which would be 600 words. Those are all the examples that I have for you for this video of Lesson 17 and 18. Please remember to do your reflection where you're writing what color you feel like you are, either green, yellow, or red. Please provide me with your own example, if you are a yellow or a green, if you're able to do so, with an answer.